Hi, welcome to Leap of Faith, transitioning from Excel to Jupyter-based application by me, Itay Dafna, the JupyterCon 2020 online conference. Just a little about me. Who am I? I'm a software engineer, currently working for Bloomberg. Been employed at Bloomberg for around 7 years now. The last couple of years, I transitioned into a software engineer role, and I'm focusing currently on building data visualization and exploration solutions. My previous roles involve derivative analysis in the capacity of financial engineering, and I also led a small team that did quant analytics. I'm an open source contributor, currently actively contributing to Wikplot and IPy widgets. So what is this talk about? Well, we're talking about the evolution of data analysis and how that evolution of data analysis has inspired an increasing number of analysts from various different industries to consider and even migrate their Excel-based applications to Jupyter-based ones. We will talk about why Jupyter is a particularly popular choice amongst these analysts and some of the difficulties that they face when attempting such migrations. Just a disclaimer, Excel is an excellent tool in data analysis, and the purpose of this talk is not to bash Excel. I am a proficient Excel user and I use it every day, even now that I can program. What we're trying to get at is, at what point is our analysis stop being a simple spreadsheet and is more of an interactive application that needs to scale with the input size? And this is what we're going to explore in this talk. So again, this is not about bashing Excel. Excel is excellent for what it was designed to do. We'll be talking about the stages of migration. So this is how we will segment this talk. When is the right time to migrate? Do we even need to migrate? How does Jupyter fit in when we are migrating? Why is it the right medium? And then the paradigm shift in the way we think about data analysis and additional considerations such as deployment and support when we are doing such migrations. So, do I really need to migrate? This is a really important question that you should be asking yourself if you're in a capacity of producing some of these apps and you have spreadsheets that are becoming increasingly complex. And to answer these questions, we will be comparing two implementations of the same app, one in Excel and one in Jupyter. This application is purpose-built. It was built specifically for this talk. And in that regard, it is not really a useful application. It is not real. This is not something that is used in the industry. We will add features to this application gradually to show and to try and find a fine line of when it has stopped being a simple spreadsheet and is now a lot more complex than how it initially started. And we will try finding that line at which we say, okay, maybe it is no longer a spreadsheet and it needs to be migrated. Maybe now is the right time to migrate from Excel to Jupyter. So what are we looking at? What exactly is this application? It's a very simple application in the sense that there isn't too much going on. We're looking at the performance of foreign exchange currency pairs. So think about how many Swedish krona does one US dollar buys me. We will look at two charts in this application. One is just a simple time series showing the evolution of the price or the exchange rate, and the other one is the performance, which is a very fancy term just to say I'm going to look at the percent change from one day compared to the other. This application is finance related, but that example itself is applicable to many different industries and all walks of life. You, for example, could be interested in doing that analysis if you consider traveling somewhere and you want to make a decision as to whether you should buy foreign currency now or later. And corporations similarly, especially in functions of procurement and salary management, payroll, multinational corporations will be interested in this kind of analysis as well. And at the end of the day, we are applying numerical analysis. We're just manipulating numbers. So this easily could be extrapolated to totally other disciplines such as weather forecasting, etc. Okay, let's jump into the live implementation of live demo of the Excel implementation and walk through the evolution of this application. Okay, let's look at the Excel application, starting with the inputs. So we have a start date here and an end date. This is for the time series. And this is the currency pair that we're retrieving the time series for. And we also have a return time series, which we're calculating based on the price time series that we have. And that's simply percentage return of one day over the previous day. The price chart here is just simply referencing the time series data that we're retrieving. And if you look at the scatter time series, same idea, only we're using a scatter plot. So far, this is very basic. An analyst will typically use that to put as a part of to generate and maybe embed in a report, either on a weekly or daily basis. But really, the inputs here don't change frequently, and if they do, it's very rarely. So for this kind of reporting or analysis, which is very basic, Excel is a perfect tool for the job. But let's say that the requirements change, and then we need a slightly more enhanced version of this reporting tool. So we still have the start date and the end date. That hasn't changed, but what we're saying now is that we're adding a period, and that period will effectively be, I want to look at 30 days, a period of 30 days ending in the end date here. And also for the currency, instead of typing the currency pair manually, I now can choose from a drop-down menu. And I can say, okay, I want to look at what how many Swiss francs one US dollar is buying me, and see how that has been in the last 30 days. Okay, and I can also change the period here. So I say, I don't want to look at 1 month, I want to look at 60 days or 2 months. And then everything here changes. Now look, there are some issues that you can immediately notice. One is the border, and we'll get to that in a second. And there are other features that you're not really seeing, which are not coming out of the box with Excel. So the chart updated with the full time series range when I change my inputs. This is not something that you get for free in Excel. In fact, this is pretty tricky to achieve. And the way we do this is by naming this cell range, giving it a name and a definition. And we do this typically on a per sheet basis. And we have to do this for each cell range that we're interested in. So if you want to have dynamic dates for our chart, we have to create a range for dynamic dates. We have to do the same for the actual price as well. So, and if you see what it looks like, currency price, yeah, that's the one. You can see that there's an offset formula here. And effectively the way it works is we are counting all the values in the column that this range pertains to. In this specific case, it's column F. And we are basically redefining the bounds based on the number of the counts of the values in that column. If you ask me, we have to do this for pretty much every dynamic cell range that we have. If you ask me, it is a bit hacky. It's not the most straightforward, natural way of achieving this. Nevertheless, it works. Now let's look at how we're doing the same, but for the performance. And again, this would be simple. We're looking at the price of a given day over the price of the previous day expressed as a percentage. But notice how we have an if statement here. And this if statement says, okay, I just need to make sure that I have enough data points. So I need to make sure that I have yesterday's price and today's price. And then if they exist, then I apply the calculation. If they don't, then I just return or output this empty string here. And if you look at the range that the return chart, the scatter chart here is referencing, you will see that it is just an arbitrarily long cell range. And the reason for that, there is no easy way of achieving this same calculation without getting into VBA. So actually, if you see here, I double click. If I double click here, that formula is still here. It's checking whether I have data to calculate the return on. If there isn't, then I just don't calculate a return, and therefore I don't have a value, which is then displayed in the chart. This can arguably, you can get by with doing this kind of Excel trickery you could have a more neat result, including getting these borders to adjust as well. If you were to use VBA, there is no simple way, in fact, there is no way that I'm aware of getting the borders here to adjust without resorting to VBA programming. Now, we are trying to illustrate the case of your average analyst in a given industry and the time investment for that analyst to then go and say, I'm going to learn VBA so I can apply this cosmetic enhancements. It's probably not worth the investment. You can just get by without doing it. So even still, for this spreadsheet and what we have here, this specific application, arguably Excel is still fit for purpose. It's still the right tool for the job. It's a bit quirky, but we can get by. But let's say that we have something different now, and let's say that this spreadsheet is popular. All our colleagues across the desk are using it, and they have asked us to add in more enhancements. So what we're looking at here is the same idea. We're just building again. We keep on adding features to our application. We have a start date and an end date given by this period. So we're saying 30 days for the time series ending on the 15th of September. For a given asset, in this case, we're checking how many Brazilian reais can $1 buy us, and give this again as like a time series. But what we've added here is the ranking period. And what this ranking period does, we're saying, I want you to look at the end date, 20 days ending in the end date, and I want you to calculate the performance for all the currencies you have available. And we have 16 currencies available. And I want you to take their average, and I then want you to rank all these currencies and give me the top 5 for that period, as you can see in here. Now, there's a lot of calculation that happens. You just don't see it in this spreadsheet, but it is there. If you look at the kind of the data that we're referencing a different spreadsheet within our workbook, and that is this data calc sheet. So let's quickly see what's happening here. I have a period of 20 days, and I have time series that I retrieve for each one of these currencies in that period. And there's a formula here that retrieves these time series, and I had to manually go and drag that formula across or copy paste for each currency pair. I had to do that by hand. It may not have taken me it wasn't much of an effort to just copy or drag one cell at a time, but I still had to do it by hand for each cell. So there's no way to easily automate this again without going into VBA. I had to then do the exact same for the return with that if statement that we saw in the previous spreadsheet. And then I also had to apply a calculation for the averaging. So for each one of these currencies, I had to, by hand, write a formula to get the time series. Based on the time series that I got, calculate the return, and then again find another way physically somewhere in the spreadsheet to then calculate the average of the return time series for that particular currency. This is arguably not ideal, and the reason we're doing it that way is that we're saying, okay, ranking period of 20 days. Really what we're trying to say, show me the last 20 days within the 30-day period that I'm referencing here. A more ideal solution would be to just say, hey, this is the overall period of time that I'm looking at, and I just want to highlight a range here in that chart. So let's say I want to look from let's say the 27th of August all the way to the 8th of September, and based on the highlighted range, I want then the table with the rankings to update and also get a return. This is something that Excel simply can't do, even with VBA. There is no way of getting that feature implemented. And this is probably the case where this is probably the point where we start wondering, okay, is Excel really the right tool for the job now that I'm really looking for a much more interactive workflow? And the answer is probably no. And that's when we should start considering migrating our analysis from Excel to Jupyter. And this is what we will continue exploring. So we've seen what the Excel implementation of the application looks like. I think we can conclude that it is no longer a spreadsheet. We were able to get by and achieve the functionality that we were looking to implement, but it wasn't the most straightforward or clean way of doing that. We had a lot of quirky implementations. It clearly didn't scale well, because for each currency that I wanted to calculate the return and then do the ranking for, I had to add another column. I had to, for each column of returns, I then had to add another column that summarizes the average return. The UX wasn't great. We were able to alleviate some of the difficulties by adding a drop-down for the currency to select the currency pair, and also we had a nicer way of controlling the start and end date, but it really wasn't fit for purpose. It would have been nicer to have something like a date selector or a slider. We had some issues and we had to make compromises on styling, so we couldn't really figure out the problem for the borders easily, again, without getting into VBA and calculating the border margins and etc. And interactivity was just not there for us. So being able to highlight a range on the chart and use that range then as an input to calculate the return and the ranking wasn't something that we were able to achieve. So it's probably the right time to migrate to Jupyter. And let's look at the Jupyter implementation without further ado. So we've seen the Excel implementation, and now we're ready to look at the Jupyter one, but just before we get into the implementation details of the Jupyter-based application, I wanted to spend maybe a couple of minutes to go over the prototyping and calculation and process of doing the data analysis that analysts who are migrating their analysis from Excel to Jupyter are going through. So typically, because in Excel your data is visible all the time, whenever you are importing your data into a Jupyter environment, typically Pandas, VIX, or any other popular data frame package, you would want to make sure that the data is there as you'd expect it to look like. So you want to visualize it, you want to get some sort of feel as to whether the data is in the format that you expected, whether the columns are organized as you expected, and whether you have what you need. So this is the first and foremost, one of the most important and probably one of the more difficult things for analysts who are migrating to do, because there's a paradigm shift in the way they're used to analyzing that data. The next thing is, if you recall, we calculated the return in the spreadsheet for each currency pair manually. We had to apply that column by column. One of the great things that the Python ecosystem gives us, together with Pandas and NumPy, is the idea of vectorized operations. So actually what we can do here is just simply calculate the return for all of these currency pairs in one go, and we have the output. So we don't have to repeat this manually for each additional input that we have. This scales beautifully, and it is one of the key differentiating factors for analysts who are migrating their work. So once we have that, we save this as a performance data frame, and then in here I am again showing examples of how an analyst in a typical situation would then start applying or experimenting with styling and potentially trying variations of different calculations to get the ranking output that they're looking for. And similarly also with any styling, if we want to create like a table of some sort that we're then displaying with color highlighting, etc., typically there will be a separate notebook where all these calculations are done. So we're ready to see the implementation of that application that we've seen in Excel on the Jupyter side. So we're going to start with just a simple HTML widget here that controls the styling. For one of my tooltips, I wanted the text color to be white, and that was the easiest way of achieving that. We are ingesting the data here from a CSV file that I've pre-compiled, but notice this could easily be any sort of API that gets the data programmatically. From the previous notebook that we worked with in the calculations prototyping, I know that this is the correct calculation. I'm confident within it. So all we have to do now is just incorporate it into our application. This is just a list of currencies that I'll be using that I'll be using as options for the drop-down menu when we conduct our analysis. Setting up two charts here, both in BQplot. One is a line chart for the time series of the price of the asset, and the other one is the scatter chart for the returns. I am inferring the start and end dates of my data set, the availability of the time series. So how much data do I have? I'm inferring it from my data set, and then I store them in a variable that I can then use for my drop-down boxes for the date selectors. Here, we're defining some callback functions. These will be called by some event listener that will listen to a change in one of the traits of the iPad widget instances that we define below. And then finally, we compose all of these into a graphical user interface, and we have our app. So let's select, let's say, the euro dollar. So how many, if I'm a European citizen, I'm earning my salary in euros and I want to travel to the US, how many dollars can I buy? How many US dollars can I buy for 1 euro? And I'm going to use the power of interactivity here to highlight a range. Let's say I want to look between April and July 2019. And for that highlighted range, I then get the scatter chart updating with the return for that period. And I have, again, all the rich interactivity that the Jupyter ecosystem gives me. And notice that I also had my ranking table updated, again, quite easily and based on the input that I am generating from my date range selector. So again, a very simple app, but we are able to seamlessly achieve and streamline a lot of the calculations that we had in Excel without too much additional effort. And this scales beautifully. If I were to make this, if I wanted to analyze 100 currencies, I could do that. All I have to do is make sure that I have the data in the CSV file that I'm ingesting, and I'll need to update the list here, which again, I could also probably do programmatically by inferring it from the columns in the spreadsheet in the CSV file. Now, this is a local application. So clearly, if one of my colleagues wants to use that, they will have to set up an environment with Python and all these dependencies here installed. This is not straightforward. But thankfully, we still have tools that allow us to overcome these challenges. So I could use a voila dashboard in here and just deploy that very same application as a voila application. And there you have it. The benefit of deploying it that way is that any changes or enhancements that I want to make to this application, I only have to make now in one place. And then we enter into this publisher subscribable kind of model, which works pretty well for smaller firms. So we've seen the Jupyter implementation of our foreign exchange application. There's quite a lot of stuff in there, so let's unpack what we've just seen. The first thing is there was a paradigm shift when we moved our analysis from Excel to Jupyter. We had to readjust or recalibrate the way we think about analyzing data. Data analysis in Python, and therefore Jupyter by extension, typically follows this pattern. You have an input. The data input, you ingest either a CSV file or you query some API and you get the data. You don't necessarily see the data. You might be able to print a subset of it, but you don't have full visibility like you have in Excel of the entire data set if you wanted. Once you're done with the input phase, you move on to processing, and that is when you actually apply your calculations, any models, munging, cleaning up, etc. That is done in the processing phase. In the video where I demonstrated the sort of thought process of how you do this as an analyst migrating from Excel to Jupyter, you saw that we had like a separate notebook where we prototyped and we sort of tested, right, iteratively to make sure that our calculations and what we're expecting checks out. Then finally, there's the output phase here, where you either generate a chart, you have your data, it's now ready and you've generated a chart, or you export that content to be then used in another context. This is quite different from what analysts are used to in Excel, because if you think about it, in Excel, these three operations, those three stages really are done in one. Your data is fully visible. It will be somewhere either in a column or a cell. You can always check the calculations. You get immediate feedback, right? If you want to change the calculation, you just double click somewhere, you edit the formula or the arithmetic, and you get an immediate output. This is quite different, and this is often where analysts are finding it challenging when it comes to migrating their applications from Excel to Jupyter, because it does require a shift in the way they think about data analysis. There are, of course, other considerations. It's not just about that paradigm shift in data analysis. A lot of them will be using the opportunity to migrate from Excel to Jupyter. They'll be using that as an opportunity to learn Python. Typically, there is a synergy there in the sense that they're adding value to the business by saying, hey, we're making the application and the process a lot more efficient by migrating it to a much richer, more modern ecosystem. But then also at the same time, they're enhancing their own personal skills. So you will often find that analysts absolutely love learning Python in parallel when they are migrating their applications. Some of them will then, depending on how much control they want to have over the visual aspects of the application, some of them will also get into a bit of HTML and CSS. Thankfully, due to the way the Jupyter ecosystem is working, and generally the widget ecosystem, JavaScript is mostly avoided. So most of them can do 99% of what they're looking to achieve just by using the tooling that they have available on the Python side. An interesting point here is that engineering resources can become a thing. Now, if you have just migrated your application from Excel to Jupyter and you're running it locally, at this point you will have set up a local environment with Python and the relative and the needed dependencies. But if you want to ship that over to your colleague, they will need to have that same environment on their machine, which is not easy. But in many cases it is done. However, you will need to have someone who can understand and can sort of work around the different desks to make sure that the environments are installed. So it starts getting into a bit of like an IT support kind of role. Now, if you are looking to deploy this from a central repository, which is fantastic, you still need to account for some resources, and that is you need to set up a server. It could be either a binder type of server, Jupyter Hub maybe, or voila. But that server still needs to be deployed somehow and to be managed. And this is not something that you can just do, as a one-off. Someone will need to manage this, and you will probably need to have a budget at some point, depending whether you want to go with a local approach or the central deployment approach. You will need to have some sort of budget as a business allocated to it. Some businesses take issue with that, others don't. But I just wanted to put that up here because this is a consideration that you normally wouldn't have when you have an Excel-based application, because Excel is by definition giving you the environment on each of the machines that your colleagues have. If they have Excel and they have the Excel file, by definition they have the environment and all the needed dependencies to make sure that that file will run. So why do analysts like Jupyter? Let's start with the fact that there is a graphical user interface. This may seem like a minuscule thing, but actually it's massive. Excel gives you this very familiar environment. Your data is always visible on a graphical user interface. It's fully mutable. Having a graphical user interface, however minimalist, is key. Then there is the idea that you get this instant feedback via the REPL. this is a big thing, right? If you want to quickly iterate over your calculation, you don't have to you run Python space some sort of file in a command line each time. So the interpreter, the IPython infrastructure, and generally how it lends itself to Jupyter is again key. So you have a GUI and you have instant feedback. Again, that segues quite nicely into the fact that you can have rich outputs. It can be a HTML table, can be just a simple white on black standard out, can be a widget. This rich output is adding this layer again, a layer of richness that bridges that gap between migrating from Excel, which is fully visual, into something that is sort of semi-visual, but not as bad or not as empty as just a simple text editor with a command line interface. Cell output are persistent. That could be useful when you want to send the calculation that you have and you just want people to see the output. To an extent, not always, but in most cases that also works with widgets. You can serialize them into static so that they have a static output. The Python ecosystem, this is a massive one. Your problem has been solved before. In the case of calculating the ranking in our FX application, we just relied on some of Pandas's built-in calculations to calculate the average across all columns, and then we just use a sorting function to sort the top 5, to sort all the columns in a descending order, and then we just took the top 5. And then, I can't say this enough, but really Jupyter is probably the ideal environment for learning Python. And I learned it on Jupyter when I first started out, and you will often find that people coming from these backgrounds where they analyze data in Excel find that, again, this minimalist graphical user interface with the instant feedback is just a very familiar and very nice environment to sort of try things out and get an immediate output of whether their calculation is right or wrong. And this lends itself quite nicely to learning Python in general. And then the final point here, which ties all of these together, is that there is just less of a gap when it comes to migrating from Excel to Jupyter, because you don't lose a lot of the features that you're used to. You have a GUI, you have instant feedback. It's not quite the same. You still have to apply, shift the way you think about data analysis, but it's much easier to digest, comparing again to moving to just bare bones text editors with a command line interface with just, white on black standard out. It's just a bit of a summary of the benefits of actually both Jupyter and Excel. We're just trying to do a compare and contrast here. So let's start with the Jupyter ecosystem. You can, again, leverage a Python ecosystem to install packages. No need to reinvent the wheel. We did have to apply calculations repeatedly for each column that we wanted to calculate something based on in Excel. No need to do that, and someone probably already solved your problem in the Python ecosystem. You can reuse old code snippets across different apps. Not easy, in fact, nearly impossible to do in Excel, because you just have to replicate that calculation each time. And that will involve a lot of copying, pasting, but thanks to classes and functions and just saving things as Python files, you can reuse your code, and generally your applications will benefit from that sharing. Deploying apps and updating your code from one location, again, you can use something like a Jupyter Hub, Binder, or Voila. Once you have that up and running, you can move into this publisher subscriber kind of model. And then when you want to move quicker with releasing updates based on feedback you get from your colleagues, these tasks become much easier. Then the benefits of Excel. Everything is visible. Again, we keep on hammering this point, but everything is visible and accessible to the user on demand. You don't have to, you can always find whatever you whatever cell you want to inspect or whatever calculation. It's all visible at all times. The costs of setting up are nil. You just run the Excel. If Excel is installed, it works. It's as simple as that. You don't have to set up any virtual environments. Deployment and sharing, and put deployment in double quotes here, because you don't really deploy, you just share your file. It's not really like a client-server kind of architecture. Nevertheless, it makes sharing much simpler because you don't have to worry about maintaining a central server or a central architecture or an architecture for a central distribution of your application. And now comparing some of the challenges, right, when it comes to using both systems. So in the Jupyter ecosystem, you need to learn Python. And depending on your circumstances, potentially even HTML and CSS, that is a big undertaking. It's nothing that should be taken lightly. When you are trying to build Python and at the same time build an application, it's a challenge. There's a new workflow, again, data not visible. We keep on touching on that point from various different angles, but changing the way you think about analyzing data is key. Deployment and sharing, right? It is a strength, but also a challenge. Deployment means that you may need to have resources. And it's not as simple as just sharing your IPyNB file and for someone else to open it like you can with Excel. Some of the challenges that you have in Excel is, I put here retrieving data programmatically from external resources, but a better way of putting it is to just say the number of add-ins and custom libraries that you have available to you in Excel is limited by definition compared to the ecosystem of Python. And that makes extensions, that makes basically making someone else who solved that problem solve it for you a bit more difficult. We've seen how quirky some of these dynamic cell ranges calculations are, where we had to use the trick with the named cell ranges and dragging this formula with the if statement down. It works, it's quirky, it's not always intuitive, it's a bit of a clunky interface. There's also scaling in here. Excel doesn't scale nicely. The calculations don't scale nicely with the size of your input. And interactivity is very challenging in Excel, right? You just can't get the same level of buttery smooth animations. In Excel, you don't have a lot of these systems where you could highlight a range in a chart and use that as an input to another function. It just doesn't exist. You've made it. Thanks for sticking with me all the way through the talk. I hope you enjoyed it and you got something out of it. If you have any comments, questions on what you've seen, maybe you are now thinking of migrating your application from Excel to Jupyter, or maybe you just completely disagree with me and you want to tell me, please feel free to ping me a message on LinkedIn or just send me a tweet. I'd love to have a conversation. Of course, Bloomberg are hiring, so if you're interested, visit the careers website. And again, thank you so much for watching, and I hope you enjoyed it.